Okay, today we're going to be talking about our dividing of rational numbers, specifically our decimals and our fractions. But before we go ahead and get started, I want to look at these two vocabulary words, our terminating decimals. And those are just decimals that have finite number of digits, which means they stop. Doesn't matter if there's one, two places after the decimal, or even three. As long as when I divide they stop, that's called a terminating decimal. Repeating decimals are those decimals where a digit or a group of digits repeat and they never stop. A very famous one is our 1/3. When I divide, I get 0.33333 and it never stops, which means I can write it with bar notation of 0.3, and when I put a bar over that 3, that means that 3 will continue to repeat forever. Same thing down here where 0.81 with that bar over the 8 and the 1, that means that group 8-1 will repeat. So 8-1, 8-1, 8-1, 8-1, and it will not stop. Now let's go on to looking at exactly how to divide our decimals. The first thing I want you to get in the habit of doing though is determining if your answer, your quotient, is going to be positive or negative before you start. Since so many people actually forget to put the sign and they end up missing points just for that. Notice here I've got a positive divided by a negative. Well, since those signs are different, that means my answer will be negative. So I'm going to put that negative down right to begin with. If I look at B, notice I've got a negative divided by a negative. Those signs are exactly the same, which means I know my final answer will be positive for B. If I put those signs down now, I won't forget later. Now we're going to go ahead and step 2, divide the problem, and we're going to use that standard algorithm, which means that division box when you've done some long division before. So I'm going to go ahead and get my division box going. And I know that my very first number in my division problem here is going to be called my dividend. That means it's going to go on the inside of that division box, 44.22. The second number is my divisor. That one goes on the outside. Now, nobody really knows their 6.7 times tables, and I need to know how many times 6.7 can go into this next number. So instead of doing 6.7, what we do is we change that number on the outside to a whole number. So that's called the divisor. And I can see that I need to move that decimal one place over. When you move it one place to the right, you're making the number larger. So mathematically, what you're really doing is you're multiplying by a power of 10. If I want to move it one place, I multiply by 10. 2 places, 100. 3 places, 1,000. So I'm really multiplying this by 10 to move it one place, and now it's 67 on the outside. The only thing I have to remember is that if I did that to the divisor, I have to do it by the same number on the dividend, which is the number on the inside. So I'm also going to multiply by 100 or move it one place to the right. Now let's go ahead and bring up that decimal, and then I can start dividing. So let's go ahead and bring that decimal on the inside straight up so I know my decimal will be right here. And let's divide. 67 cannot go into 4. It cannot go into 44. It can go into 442. Now, not a lot of people know their 67 times tables. So you could go with the side and say 67 times 3, 67 times 5, and see which one is the closest. Or you can do what they call estimating. Now, hopefully you agree 67 is close to 70. So if I rounded, that's about 70. And now, if I kind of forget the number outside and forget the last number inside, I can estimate and say, well, about how many times can 7 go into 44? Well, 7 times 6 is 42, and that's about as close as I can get. So I know by using that, what we call estimation, 70 can go in about 6 times. I think 67 should go into 442. about 6 times. Now let's go ahead and multiply. 6 times 7, that's what I did right here, is 42. That's why I put down the 2, and I'm going to carry the 4. Now do the 6 times the next number. 6 times 6, which is 36, plus the 4 is 40. Now subtract those numbers, and I get 40. I have another number to bring down, 2. How many times does it go into 402? Well, isn't that the number we just got when I multiplied it by 6 here? So I know it's 6 again. In fact, I don't even have to multiply again. I know what it's going to be, 402. And when I subtract, I have no decimals, no remainders. So I already had my negative in front of it, so I know my answer is 6.6, negative 6.6. Now let's go ahead and look at this next one. Same thing. I have to put my division box. My dividend, 78.74, goes on the inside. That 12.7 goes on the outside. And yes, I can't have that decimal, so I'm going to move it over one place by multiplying by 10, which means I'm going to multiply by 10 on the inside. Now let's bring that decimal straight up, and let's do some dividing. Now 127 cannot go into 7. It cannot go into 78, but it can go into 787. So 125 is around what it is. I know that it's going to go in about 6 times. So let's go ahead and multiply. 6 times 7, well, that's 42. Carry the 4, put down the 2. Then 6 times the 2 is 12. 12 plus the 4 I carried is 16. And then 6 times that 1 is 6, plus that other 1 is 7. Let's subtract those numbers, and I get 25. Now let's bring down that 4. 127 can go into 252 2 times, and when I go ahead and multiply, I should get 254. When I subtract, I have nothing left over, no remainder, which means my answer is positive 6.2. Now let's look at our fractions. But there's one other vocabulary I want you to know before we get started, and that's multiplicative inverse. Another name for multiplicative inverse, I'm sure you've heard, is reciprocal. And that means two numbers whose product is 1. So if I give you 2/3, like I did here, the only way to get 1 is to flip it over to get 3/2. And when I multiply, I can see I get 6/6, which is 1. Here, I give you the number 2. Well, if I flip that over, that becomes 1/2. That's our multiplicative inverse. And that means when I multiply them together, I would also get 1. So the only difference when I multiply with fractions is first, again, decide if that quotient is going to be positive or negative. So if I have a negative divided by a positive, you should know by now your answer will be a negative because they're different. When you multiply and when you divide with fractions, you cannot have mixed numbers or whole numbers and regular fractions. So I need to change any mixed number or whole number to that improper fraction. So there's definitely a mixed number right here, and we're going to go ahead and change that to an improper fraction by taking that 6 times 4, which is 24. We're going to add that 1 to be 25. 25/6 divided by, and we have a regular fraction, 1/3. That's my new problem so far. Now, just like with subtracting with math means to add the opposite. Well, when you divide with fractions, that dividing actually can be changed to multiplication. We're going to change any dividing with fractions to multiplying by the multiplicative inverse, which means we're going to change that division to multiplying, but we're going to change that second number right there into its multiplicative inverse, flipping it over. So this becomes 25 over 6 times 3 over 1. Now, let's cross cancel if we can. Can I reduce 25 and 1? No. Can I reduce a 6 and a 3? Yes. 3 goes into both. So let's divide those both by 3. That becomes a 1. That becomes a 2. Now, just like with multiplying our fractions, let's multiply our numerators. 25 times 1 is 25. On the bottom, 2 times 1 is 2. And now simplify. I cannot have my top bigger than my denominator. How many times can 2 go into 25? Well, that's 12 times. That's only 24 though. How many's left over? 1, and my denominator stays a 2. So I know when I divide I get 12 and 1/2, but remember up here we already put our negative sign, so our answer is actually negative 12 and 1/2. That is my final answer. Make sure your notes look like this, and I will see you in class.